All right, so in our first video, we learned what a perfect square trinomial is and how to complete the square. In this video, we're going to remind ourselves of the factoring pattern for a perfect square trinomial, because once you pick up the pattern, it's really easy. So let's review factoring the old-fashioned way. The way we've done it at Eagle Crest is we have often made this little X where we'll say, all right, what happens if I multiply the first and last term and I consider the middle term and I look for two numbers that have a product of the first and last, so in this case 36x squared, and a sum of the middle term, negative 12x. So if we think about the numbers that have that product of positive 36 and sum of negative 12, we know those numbers have to have the same sign because their product is positive, but they have to be negative numbers because their sum is negative. So if I think about it, the only numbers that work are negative 6 and negative 6. So because our coefficient of the quadratic term is 1, in other words, we just have an x squared. We don't have like a 5x squared. We don't have to go through the long steps of factoring by grouping. I know that when I factor this into two binomials, that the first two terms of each binomial have to make x squared. So those each have to be x. And then I know that the inner and outer terms have to add to negative 12x, and the last terms have to multiply to positive 36. So those two negative 6's we got, like that's all we need. So this factors to x minus 6 times x minus 6, which we could then rewrite as x minus 6 squared. So all perfect square trinomials are going to factor to a single binomial times itself. It's just a matter of recognizing the factoring pattern and just figuring out like what that number has to be and if the sign is positive or negative. So I'm gonna scroll down here, and if we look at examples 1 and 2, we can always go back and factor the old-fashioned way. But I'm going to actually look at example 1 from the answer and work backwards. So from example 1, let's say that I consider, I'm going to do it to the left, x plus 5 squared. And I know that's x plus 5 times x plus 5. So just like we did on our last video, when we distribute the terms from the first binomial to the second, sometimes we'll say FOIL for first, outer, inner, last. The first two terms give us x squared, the inner terms plus 5x, the outer terms, the inner terms also plus 5x though, and then our last terms give us a plus 25. And then we could write that as x squared plus 10x plus 25. So remember that that outer number, that third term, is always a perfect square. And if we take its square root, so like the square root of 25, for example, that gives me the number that's going to be in my binomial. So this x plus 5, I can find out that that number's got to be a 5 by taking the square root of this 25. Also, the sign, the fact that this is positive, well, where the sign shows up is when we multiply our outer and our inner terms. So it's when we do x times positive 5 and positive 5 times x that we get these two plus 5s. So it's this, the fact that this is positive, a positive 10x, that tells me that when I put this in factored form, it will be addition. So let's go through the second example real fast, and I'll just tell you how I think of this shortcut. First of all, this only works with perfect square trinomials, so I have to know that the polynomial I'm working with is in fact a perfect square trinomial. And I know that because x squared is a perfect square, 16 is a perfect square, and then when I look at this negative 8x, well, if I take the square root of 16, which is 4, and double it, it doesn't matter if it's positive or negative, I get 8. So that's just like a way I can check that it's a perfect square trinomial. So now I'm just going to take the square root of the first term, x squared, so its square root is x, the sine of the second term, subtraction, and the square root of the last term. So the square root of 16 is 4, x minus 4 squared. That's all you got to do. All right, so I just want to emphasize that if you forget the pattern, you can factor all of these the long way. Like you'll get the right answer if you factor just the regular way. But let's look at how fast this goes if we recognize the pattern. All right, so this one, when I convert this into factored form, square root of my first term is x, sine of my second term is plus, square root of my last term, the square root of 1 is just 1, it's 1. So that would factor to x plus 1 times x plus 1, which is just x plus 1 squared. All right, we'll go through these kind of fast. Next example, square root of my first term is x. The sine of my second term is still addition. The square root of my last term, the square root of 4 is 2. X plus 2 squared. All right, then I'm going to have x. This is my first subtraction. Minus square root of 9 is 3. So x minus 3 squared. So take a moment, pause the video, and work these out, these remaining 4 examples, and then check in with me when you have done that. All right, I'm going to assume you paused the video. I have no way of knowing. This next one should be x minus 4 squared. This next one, x minus 5 squared. I think I went in order when I made these. X plus 6 squared, don't miss that change to addition. And then this last one is x plus 7 squared. So it's not really hard when they're going in increasing order like that, but I think I did it that way deliberately so that you could see like the pattern that emerges between each one. You'll also notice that the second term, when we factor this, is always half of that middle term. So again, like that's not a coincidence, that's just the structure of a perfect square trinomial.